Hello. I'll show you what a Pascal's triangle is. It's actually really cool. So basically it's going to be a triangle, but it's actually filled with numbers. Okay. So basically it starts off with a 1 and then branches out. And then basically the pattern is that all the diagonals or the starting numbers are 1. Okay, so basically yeah, you start off with 1 and then you branch out to more ones, and then you take the sum. The inside numbers are the sums of the numbers that are above them, the two numbers. So here the sum of this 1 plus 1, which is 2. Okay, and then branch out again, and then this time a 3, but ignore this. I want to show you what the triangle looks like. Okay, and then now we have 4 or 3 different sums. So 1 plus 3, 4, 3 plus 3, 6, 1 plus 3, 4. And then basically I'll do one more. It just basically continues like that. Also 1 plus 4 is 5. And then basically you can see it literally goes between them. That's how the triangle creates. So 4 plus 6, 10. Same thing again, 10. 5. Okay, so you can see it's a triangle shape. And basically, yeah, so the pattern is it's the sum of the number above it. And then also, the way you would notate it is that this is row 0, right? And then so on. So this is row 1. This is a row 0. This is row 1, 2, 3, 4, 5. And if you notice, the row actually corresponds with the second number. Except for the first one because it's 0. And then also another pattern is that if you look, there's something called a hockey stick pattern. Basically you start off with 1 and you continue, and then suddenly if you take like the opposite direction, you see how it creates like a hockey stick shape. Basically the sum of this number, sum of this number, this number, this number, and this number should add up to this number. So if you can see, 3 plus 2 is 5, 5 plus 4 is 9, 9 plus 1 is 10. I'll do another example. You could go the other way too. So for example, you could go like this. So 2 plus 5, sorry, 2 plus 3 plus 1 is equal to 6. That's the hockey stick pattern, okay? And that is the Pascal's triangle, like the basic concept of it. And it continues on forever. And then I'm gonna show like an application kind of question. So basically, pretend that this is like a checkerboard, and you're trying to figure out how many different ways this checker can end up either one of these spots. Like how many different possibilities or how many different routes it can take. So basically, we'll use this color. Okay, so basically starting from here, you have one option to go that way, and you have one option to go that way, right? So 1 and 1, because you only have one option. Okay, and then from this one right here and this one right here, you have two options, because you can come from here or from here. Okay, and then from here you can only go one direction and one direction this way. And then if you can see, the Pascal triangle is being created. And then from here you can have two possibilities, and then from here you have one possibility, so that becomes 3. From you have 2 and 1, it becomes 3. And then from here you have 1 and 1 this way as well. And then I'm just going to continue this. So 1 possibility, and then from here you have 3 and 1, which is 4. From here you have 3, from here you have 3, which is 6. And then from here you have 3 and you have 1, which is 4. And then this one doesn't continue anywhere because it stopped. And same thing with the other direction. So then here you have 1 and 4, so 5. Here you have 4 different ways and 6 different ways, which is 10 different ways. And then same thing here. 10 different ways. And then here, if you look, there's only one possibility. Nothing can come from here because there's nothing there. So this would stay 4. And then same thing here. There's only one possibility, which is the 5. Here and here we have 15 ways to get here. And then here and here you have 20 ways. And then here and here we have 14 different ways. And then here and here you have 20 ways. Here and here we have 35 different ways. 34 different ways, and then finally you only have one way to get here, which is the 14, so 14 ways. And then, so basically, if this checker wants to get here, it has 20 different possibilities to get there. And 35 there, and 34 and 14. And you can see it actually created a Pascal triangle, and basically the parts where it ended, it kind of just continued because it only has one path. So like here, technically it's not part of the Pascal triangle, but because you have to kind of play with the restrictions and stuff, you continue it like that. That's the only part. And then if you want to figure out like all the possibilities for the checker to come to the bottom, what you would do is just add all of these numbers together. So 20 plus 35 plus 34 plus 14. And I think you should get 103 ways. And that's basically the Pascal triangle.